Jack. Welcome to my math party. What we're going to go through this lesson is quadratic equations, completing the square, and the quadratic formula, or as I like to call it, a calculator you carry in your head. First, let's jump into the basics of quadratics. Quadratic equations, ones we have to deal with in math class, are usually based on a couple of binomials multiplied together like this: x minus 5, say x plus 3. Okay, now multiplying this is an expression right here. It's not an equation because we don't have an equal sign and we don't have anything on the other side to compare it with. So the best we can do here is to simplify, and what the instructions are telling us here is we need to multiply these things. But the order of operations, parentheses, exponents, multiplication, division, addition, subtraction, tells us that we have to do the work in the parentheses before we can do the multiplication. Well, we can't do the work in the parentheses because the stuff in the parentheses are not like terms. They have to have the same letters based on same letters, and those letters have to be to the same powers before we can add or subtract them, and that's not what's going on here. Okay, so it means we can't follow the parentheses rule. Don't have any exponents we have to deal with, but we still have to do the multiplication and division. So it means we multiply everything in one set of parentheses by everything in the second set of parentheses. In other words, 4 separate multiplications. I just did x times x is x squared. Now I'm coming over here and going positive times positive is positive. 3 times x is 3x. I like to do signs and as a separate operation because, man, it is really easy to make a mistake with signs. See, here we have a negative times positive is a negative. 5 times x is 5x. And again, we have a negative times positive, which is again a negative. Same signs plus, different signs minus, but that's only for multiplication and division of sign numbers, integers. Okay, 5 times 3 is 15. Now we put together like terms. That's these two guys have the same letter to the same power. Bring the x squared down. 3 minus 5 is negative 2. Bring the x. Bring down minus 15. And there we go. Okay. Now, like I said, this is an expression, not an equation. Let me show you what we mean by how we would treat an equation. So we have that same thing, x squared minus 2x minus 15. We made it equal to 0. Well, then when we break it apart into x minus 5 times x plus 3, we can turn each of these little binomials, turn each of these binomials into like little miniature equations. Plus 5 plus 3. Okay, rule 1 in math: do not let the mouth overload the brain and the pencil. This is plus 3. Follow the arrows, and it also equals 0. Okay, now we just solve for x on each of these little itty-bitty equations, and we get 2 answers. Why are there 2 answers? Well, I'll tell you the easy answer to that. And these are both the answers. Both of these will turn this into a true statement if we replace it for the x. Well, the easy answer for why there are 2 answers is because the x is squared. See, if we had like this square root of, well, anything that has a square root, I like 25. Okay, the square root of 25, the number that multiplied by itself and gives us 25 is 5. Well, that's a positive 5. You notice that also works for negative 5. And negative 5 times negative 5 is positive 25. Negative 5 and positive 5 are not the same number. Okay, positive 5 means you got $5 in your hand. Negative 5 means you owe somebody $5. You would rather be Somebody with $5 and somebody owing $5. At least I would hope so. Okay, this is how you solve using factor and solve. Now there's another technique that I'm going to go into. It's called completing the square. And we're going to do the same thing we did right here, only we're going to use a different set of steps. Okay, and let's see. I'm going to go ahead and erase this here whiteboard, and we're going to go ahead and start it again. And I'm going to first let me write out our equation. X squared minus 2x minus 15 equals 0. Okay. Now, here's the steps for completing the square. Okay, step 1, the number attached to the squared variable must be a positive 1. When I use the word variable in these steps, I just mean the x, okay? Okay, well, the squared variable here is x squared, and the number in front of it is a positive 1, so we don't have to worry about step 1. Step 2, put the term without a variable on the right side of the equal sign. Well, this negative 15 is a term without a variable. Let's go ahead and put it over on the right side of the equal sign by breaking the negative that's holding it on the left-hand side by doing the opposite of negative, doing positive. Okay, that is step 2. Let's look at step 3. The crazy part. Oh, this is my favorite part. Add to each side the square root of 1/2 of the number attached to the non-squared variable. Okay, or as I originally read it, add to each side the square of 1/2 the coefficient of x. Okay, this step works better if you take it backwards, okay? First, let's take the number attached to the non-squared variable. Well, first, the non-squared variable, well, that's our x right here, that negative 2x, okay, that x, that's a non-squared variable. Okay, the number attached to it is a negative 2. Okay, 1/2 of that number, well, we're going to take this and multiply it by 1/2. That's how you find 1/2 of anything, is just multiply it by 1/2. Or divide by 2. I prefer multiplying by 1/2 for this particular thing. Okay, and then square it, and then add that to both sides. Okay, here's what we do. The coefficient, the number in front of the non-squared variable, what's negative 2? Well, I need to find 1/2 of that, so I'm going to multiply by 1/2. That gives me negative 2 over 2, which is just negative 1. Any number divided by itself is 1. And negative divided by positive is negative. Okay, we need to square that. And that gives us positive 1. Now we add that to both sides. X squared minus 2x plus 1 added to both sides equals 15. Don't forget the 15 that was over here. And plus 1. See, we added it to both sides. The reason we did this is this x squared minus 2x minus 1 factors into x minus 1 squared. And 15 plus 1 is 16. Okay. Now we apply the even root property. In other words, take the square root of both sides. Let's go ahead and, there we are. Let's see. Okay, we did this, the whole thing. Now this step 3, the whole reason for that is so that the left-hand side of the equal sign will factor into a perfect square trinomial. Okay, 2 terms, binomial squared. Okay, even root property, all that means is just take the square root of both sides. Square root of this is what was inside, and it's because they were the x and the negative 1, x minus 1 was in parentheses, and they're all under the same radical. They just come straight out. Over here, because this is an even radical, remember that plus and minus thing from there being 2 answers? Well, guess what? Here we go. That's where they are. Now we're going to take this. I'm going to move it up because my screen capture software doesn't capture my whole whiteboard here. Now I'm going to solve for x. In other words, I'm going to have to take that -1 and move it over to the other side. By going +1 and +1. Now, this +1 over on the left side, that's -1 plus 1 is 0. All we have is x. This +1 I'm going to put right up in between that plus and minus sign and the equal sign. That's 1 plus or minus 4. Here's where our two answers come from. Sorry, there's a button on the pencil that makes it do crazy things sometimes when I press it. Okay, here we got 1 plus 4. And down here we've got 1 minus 4. 1 plus 4 is +5. See, there's that +5 again. 1 minus 4 is -3. Ta-da! There's our same answers again, completing the square. Now we're going to use the quadratic formula. I'll go ahead and clear the whiteboard here. As a matter of fact, I'm going to do a trick, okay? Quadratic equations are, the general form of quadratic equations are ax squared plus bx plus c equals 0. Yeah, I call this a roadmap. It shows you where the a's, b's, and c's are for when you're using the quadratic formula. But what I'm going to do here is I'm going to use this ax squared plus bx plus c equals 0. And I'm going to do completing the square on it. And let's see what happens. You know, for the heck of it. All right, the number in front of the squared variable must be a +1. The number in front of the squared variable is letter A. It's not a +1. The way to turn anything into a +1 is just divide that thing by itself. But if we divide something in an equation by something, we have to divide everything by that same thing. Here, anything divided by itself is 1. 1 times x squared is x squared. Plus, now I'm just going to take the b and put it over a, because they're not the same thing. We don't know what numbers they stand for, so they just stay like they are, just like this c over a. I don't know what number c is. I don't know what number a is. They just stay that way. But I know that 0 divided by anything is 0. Okay, now let's see. That was step 1. Getting rid of the 1 in front of that x squared. Step 2, take the term without an x. This is what I meant when I said what I call variables in this x. Well, that's what I meant. C over a, that's the term without a variable. We need to move it to the other side of the equal sign. And we do that just by breaking the plus sign that's holding it on this side. And if you do it to one side, you need to do it to the other side, just like that. Anything minus itself is 0. So we're left with x squared plus b over a x equals -c over a. Now it's time for the crazy step. Add to each side the squares 1/2 the coefficient of x. The coefficient of x, the number in front of x, is b over a. You need to find 1/2 of that. Well, no problem. Multiply by 1/2. Gives us b over 2a. Now we need the square of this. Now keep in mind that square affects everything inside those parentheses. So this is b squared and 4 and a squared. Notice everything in there was squared. Now we add this to each side. This side is x squared plus b over a x plus, here's our b squared over 4a squared. Here's the equal sign. Don't forget that negative c over a, but I'm going to go ahead and put this b squared over 4a squared, b squared over 4a squared. Now that's really sloppy. Going to go for the eraser. I'm going to put it on the left side of the negative c over a, just because, well, you'll see why when I finish. B squared over 4a squared, and then I'm just going to bring down that negative c over a. It was already there. All I did was just wedge this b squared over 4a squared in between the equal sign and that negative sign. Now this side right here, the left side, will factor into, first put an x, then take the sign of the middle term. In this case, that is positive. See, positive b over ax, that's the middle term. Then we go back to the whole step 3 thing. You take that middle term after you did the 1/2, but before you squared, that's what goes right here. b over 2a, close the parentheses, and this is squared. And if I multiplied x plus b over 2a times x plus b over 2a, I would get x squared plus b over ax plus b squared over 4a squared. That was the whole point of the whole add to both sides of the square of 1/2 coefficient of x. Now, over on this side, I need a common denominator before I can add or subtract. And to turn a into 4a squared, I need to multiply by 4a, but anything you do to the bottom of a fraction, guess what? You need to do the same thing to the top. So here this gives me b squared minus 4ac, numbers first, letters in alphabetical order. That's the way math teachers like to see it. And this is all over 4a squared. Now, if they have the same denominator, I'm just going to put them over the same fraction. It's a lot more efficient that way. Okay, well, we're solving for x, and x is all inside this set of parentheses with the exponent and all that kind of crazy stuff. So the first thing I need to do is get rid of that exponent by taking the square root. Since it's a square, take a square root. But if you do something to one side of an equal sign, you need to do the same thing to the other side. Now here, this stuff is all up inside the same radical. So it just comes straight out. X plus b over 2a equals. Okay, now here I don't know the square root of b squared minus 4ac. I don't know anybody who does. At least before we start filling a's, b's, and c's in with numbers. But I do know the square root of 4a squared is 2a. Okay, I'm going to go ahead and move this all the way up here because I'm running out of room. Okay, so this is x plus b over 2a equals square root of b squared minus 4ac over 2a. And another thing I know about square roots, don't forget the plus or minus, like I almost did. Now, again, we're solving for x, okay? So I need to get rid of this b over 2a, and I'm just going to go minus b over 2a on both sides. Do it to one side, do it to the other. Now here, anything minus itself is 0. The only thing left on this left-hand side of the equal sign is x. And x equals, okay, well, here's the b, negative b, because we have to subtract it, plus or minus the square root of b squared minus 4ac. And this is all over. Notice it was over 2a, so since it's over the same denominator, just write it out like that, and look at that. We have created our own quadratic formula. Okay, you feed numbers into that, you get answers out. Okay, we're going to do one more step. We're going to go ahead and solve that same equation using our good friend, the recently created quadratic formula. Okay, let me clear the canvas. Campus was already cleared by the COVID. Okay, we're using x squared minus 2x minus 15 equals 0. We're going to follow the map. Ax squared plus bx plus c equals 0. That means a, in this case, equals 1. It's the number in front of the x squared term. B is negative 2. C is negative 15. And we're going to use them to fill in the blanks. Here in x equals negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so we're just going to fill in the blanks. Negative b. B happens to be a negative 2. Okay, that's going to turn positive. It's important to remember whenever you're replacing a letter with a number, put that number in parentheses, because sometimes it makes a huge difference. Sometimes it doesn't make any difference at all. This is not one of those times. Okay, b squared, that's negative 2 squared minus 4 times a, which is 1, times c, which is negative 15. And this is all over 2 times a, which is 1. Well, yeah, don't forget the x equals. So x equals negative 1 times negative 2 is positive 2. That's what this means. That's a negative 1 there. We now have a 1 written there, but it is there. It's invisible. If you ever hear anybody call that negative 1 in front of the set of parentheses in imaginary, you tell them they're wrong. It's not imaginary, it's invisible. You just can't see it, but it is there. Negative 2 squared, positive 4. Negative 4 times 1 is negative 4. That's going to be times negative 15. I'm just going to go ahead and do all that multiplication now. So that's negative 4 times 1 is negative 4. Negative 4 times negative 15 is positive 60. And this is over 2 times 1, which is 2. So this is x equals 2 plus or minus the square root of 64 over 2. Okay. So that's going to be x equals 2 plus or minus 8 over 2. This is going to break into two different things. Equals 2 plus 8 over 2, and it equals 2 minus 8 over 2. Well, 2 plus 8 over 2 is 10 over 2, which is positive 5. Hey, look, there's that positive 5 again. What about our negative 3? Well, let's find out. 2 minus 8 is negative 6 over 2, which, guess what? There's our good friend, the negative 3. All right, now you know 3 ways to answer any quadratic equation. Okay. Thank you for your time and attention. I will see you on the next video. And until then, have fun and make all your math a party.